G'day guys, got a good little experiment for you to watch because keep arguing with people about pulse inductions or pulse induction detectors. Um, makes no difference if you use ground between the coil and target or air between the coil and target. Anyway, what I've got on the bench, I've got a GP, spin around. I'm still recovering from that rotten COVID flu. um, yeah, and it's yeah, it gave me a sore throat and voice a bit funny. But anyway, coming good bit by bit. Didn't do anything else to me, so it's overrated. Um, yeah, GPX 5000 is a customer's job. He just wanted all the front end and variable frequency put in. He didn't want the variable gain put in. He wanted to be stealth detector, right? So he just wants to, I think he just wants to outperform his friends using standard detectors anyway. And they won't be able to work out what's going on because he's not going to tell them. Anyway, that goes the story. Back onto this. As you can see, I have, follow that cable up there, I've converted my twin coil, anti-phase coil setup to run on a double D cable. And I had to pull this off one of my double D coils because I got some cable in from, I won't mention the country, but I got some cable in. It was specified as well, the right type of cable, double D cable. And yeah, it totally, I don't know why, it totally still hooked it up. It wouldn't perform. There was really hardly any, well, greatly reduced transmit output and greatly reduced receive input. Yeah, what's going on here? And we did some tests on the cable, and you know, oils ain't oils. Well, copper ain't copper. It was about maybe 80% copper, and it had so many additives that it completely destroyed the conductive, or you want to call it, you know, um, current carrying capability. It basically increased the resistance of the wire and burnt up the energy as heat. That's all it can do. So, yeah, our cable, yeah, we can make power resistors out of it or something, I suppose, or frighten a bin. Beware what you get. My God. I hope the other people out there making coils haven't got the same stuff. But I went through and checked all the other mono cable I've got. I went and checked all the Litz wire I've got. It's damn 98, 99% copper, thank God. And it's just one you wouldn't even look for, that you would find that copper ain't copper. And there goes my voice, it's slowly fading away. But anyway, I want to show you this. Okay, so let's have a look. I'm in normal mode, okay? It's pretty quiet. The detector's on full, well, it's factory standard. I can't say full gain, it hasn't got variable gain, but it's factory standard. So let's go over it. It's normal mode. I don't know, 6 or so. No one knocked that over. But say we're looking at 6. We can get 6 in air. Okay, I might turn the volume up. It is a little bit soft. Yeah, it's full. It's flat biscuit. Yeah, flat out. Like I say, normal mode. That's a 0.1. You don't expect much in a normal mode anyway, but we can get that easy. Remember, you won't get that on a standard detector. You'll be rubbing that on the coil. But anyway, let's do something and prove a point. Say we get it 7, okay? I'll get this. And I'm going to upset the poor coils, but I'm going to do this. Okay? And what I've put on there is a great big stack of pure ironstone. And when I say pure ironstone, magnets. They're magnets. I put the magnets in a bag. It's a good reason I did that, because you can't get the stuff off the magnets. Okay, so that's what I've got sitting on top of the coils. Massive layer of pure ironstone. It's just picking up the magnets because they're made of metal. But anyway, you have to put up the noise because there we go. Don't dip your magnets directly into ironstone. Anyway, it's a nice bed of ironstone. You would never detect on that. You wouldn't find it to detect on. I don't think that's been collected. So what we'll do, put it under there. I could do it the other way. It's not going to make much difference anyway, really, when you think about it. Or maybe it will. I don't know. But let's see if the reactance of that ironstone has any effect. I don't know if I'm going to get the ruler to stay there now. Hang on a sec. How do I get some post-it notes and stick it under the back of the ruler? Keep it there. Yeah, something like that. I think that's good enough. So we got all that ironstone there. I'm not even bother going to re-ground balance or anything. Just wondering how far we can get it. Is this stuff going to absorb all the energy from the pulse induction detector and make the field die off? Because that's what's happening. Doesn't matter if I'm here or there. Wouldn't make any damn difference. But anyway, let's go over it and see what happens. 0.05. Maybe it's down a little bit, somewhere around just over 6, I think. If I get my eyeballs down to the right level. I can still hear it at 7. I don't think there's any damn difference. There shouldn't be any difference. That's the whole thing. There should be no difference. I could put this directly, or sit this directly on top of the coils, as probably people would love me to do. I might as well do that, just see what happens. It might be bordering, especially in normal mode, because normal mode on something super hot usually has a real hard time ground balancing, so we might see the same. We'll do it anyway. There we go. This is going to absolutely, you wouldn't do this. I don't even know if we can ground balance that. So, I think it'll just scream its head off. We'll see. Hang on, I've got to go flick it into fast track because it won't track. Let's see how I can do this. Normal mode, okay. Keep trying. I don't think it'll track that in a million years. I could do it in enhanced, but then I've lost my reference. But anyway, just try it and see how it goes. Okay, so I can set up this at the back. Get the heights right. So that spacer goes there. That ruler goes in there. 0.05. Let's see how we go. Can we detect through this stuff? Yep, I can hear it. Get it up at 7. It doesn't have any really great effect. So, you know, this bizzo of air tests and ground tests, I mean, that's really asking a big lot out of the detector. Big layer of pure ironstone. I mean, that's really out there. I don't think anyone normally would do something like that, but that's what it is. Fully magnetic. Okay, as a matter of fact, how about we do this? How about, I need a bigger target to do this, especially because we're in normal. There's a ring. How about we use a ring? Okay. It's going to go right at the top of the ruler. This is an extended ruler, so I might have to adjust the camera angle on this. So we'll go up the ruler, way up there somewhere. I think we want to be. Amazing my voice hasn't disappeared yet. But anyway, we'll see how we go. I think 35, 36. What I'm going to do now, that's heavy. Big tub of Denali dirt. And I've got the ring in my hand, so it's going to set it off. But anyway, so here we go. Okay, big tub of Denali dirt. Ring. Let me get over here a bit so I can swing properly. $35, $36. No damn difference. Okay, let's try this. Ironstone, super reactive. That would be equivalent to something like about 4 or 5 feet of normal ground, easy. Let's put that on top. Okay, all sitting there nicely. Use the same ring as a thing. I bet you it makes no difference. Up around 35. I think it's the same. It's just very, very, maybe like 1 or 2% less intense, if anything. It's really nothing. So, to a pulse induction detector, unless it's very, very super pure iron type stuff or any sort of metal, it's going to cut through it. It's not going to really have much effect on the electromagnetic field. So, it amazes me how heavy this stuff is. It is just full of minerals, and it's not like normal dirt. This stuff weighs an absolute a lot. You know, sit there. Hope my shelving doesn't fall down. So yeah, basically go back to an air test again. 35, 36. There's nothing in it. There's nothing in it whatsoever. So You know, people with their reactive ground theories and whatever else disproved it doesn't have any effect. The only thing it would have an effect is if you are moving the coil over discontinuous ground, that is high and low in mineralization. That will affect the ground tracking capabilities of the detector. And if it can't track fast enough or whatever, you'll lose gold. You'll lose signals. And if you're tracking too fast, you may lose gold as well. Anyway, it's a story for another day. What I could do, I could set up the Gold Monster, which is a VLF machine, and do the same test with that. I guarantee you, it won't go through the ironstone. It will not do anything. It will just die, right? I know for a fact it will not cut the mustard with that. It's really sort of a waste of time of doing it, but I can do it. But it's just going to go completely bonkers. It won't be able to handle that much mineralization like a PI, and it's going to have no depth. It just will not have any depth whatsoever. It's going to have a big impact. VLF detectors, like all these little tiny screaming gold machines, but the PIs now are screaming gold machines because you can make them that way. Yeah, well, I think most people out there know about VLFs and they just don't go through mineralised ground. They'll go through inert ground, but they won't go through mineralised ground. I'm pushing it. I'm really pushing it. I don't think anyone would have ever have done that anywhere. With that sort of ironstone content, it's just crazy. That will upset your ground balance too. It might push it so far that the detector won't balance. That's another thing I've been working on. Depending how far you push these detectors, that on some super hot ground, it can cause a ground balance issue. I'm trying to expand the range of the ground balance and have it track better. There's a lot of things I've been doing. So God, listen how quiet that is. That's just sitting there purring away. That's just awesome. And it is. It's absolutely flat out. It's just, you know, just crazy. So that's how, when you get in there into these detectors and you can tweak and balance things, it's in dual channel mono, by the way, and I've got these one phase flip. So one's acting as a cancel, and but basically it's going through both input channels, and because they're so well balanced, that they really get rid of all the noise. So I hope that was educational to a degree. Speaking of educational, it's sticking up in the air still. But yeah, there it is there. And now we've got a nice long double D cable. Guys, I tell you what, because I got a bum deal out of that country that Trumpy hates so much, and if any of you got broken double D coils, if you got broken ones, I don't mean like, you know, I don't care. I just want the cable, right? I need the cable off them double D coils. And yeah, if you got double D, you don't want, throw it my way. If you want some dollars for it, throw it my way. Yeah, I've got to actually set up with another manufacturer to get some double D cable made, because double D cable, as I've been talking to people overseas and whatever, no one wants to sell you cable. They will not sell you cable. If the Asians start making um, a double D cable that actually worked, that was properly made, then the locals would probably sell you the cable because they've got no choice then. They haven't got the market sewn up to themselves. And it's with mono cable. You can buy, most of them will sell you mono cable, maybe with plugs on the end as an extension. They just want to keep other people out from making coils, basically. I can understand that. They don't want to start giving cable away so people can make coils. But if you want mono cable, it's freely available out of China. I mean, oops, I said that word, out of Asia. And It's nothing wrong with it. It works fine. Yeah, that's what I was using. As you can see here, I hope it focuses. I have to get behind the camera to look. That's mono cable. Call it out of Asia, and it's spiral. It's wound. It's nothing wrong with that. That's been overheated probably or something. But anyway, and it's no, it's not. It's got a bit. It's got a bit of stuff over it. It's got solder and it's got a bit of tape around it. So yeah, there's nothing wrong with this stuff. And you know, it was a bit horrible because I had to modify it and stick two cables onto a single plug to use the counterphase coil, and thus, you know, it's just too hard to manipulate. It's like trying to bend steel. Not that bad, but if you know what I mean, you're trying to stick into detectors off the workbench. It's very, very hard to bend and it's hard to get an angle. You could basically hang the detector off that if you held it like that, you know. So yeah, I just went and said, "I'll get some double D made up," and yeah, come a cropper with that, which is to be expected with dealing with some countries. Just the way it goes. So you always do samples and always use a go-between as oh, what do you want to call it? Like a middleman that controls the money. So when you get the product, if it's not up to spec, you say so. And yeah, until it's rectified, well, the other party doesn't get paid, and you don't release the funds. Anyway, that's the best way to do business because what are you going to do? You're going to take a Asian company to court through an Asian court system. You won't win. I tell you, you'll lose. So protect yourself. Yeah, that's right. You call it escrow service. Uh, even on Alibaba, they have an escrow service. So that they don't want, they'll get a bad name if companies keep doing nasty things to overseas clients. So yeah, they run an escrow there, and if you're not happy, they don't get paid. So it sort of forces the issue. So yeah, that's where we're at with that. As you can see, I'll show you what I did with this coil setup too. By the way, uh, I went down and I got a spare one, but that's a small one, basically a chopping board, and it's quite, I don't know what it's made out of, polyethylene, something, whatever. And yeah, I just stuck the coils on, marked it out, and drilled holes around and locked it down hard because if the coils move and you're doing measurements, it's going to give funny results. So I thought we'll just settle everything down, lock it in hard, and it can't go wrong. Now, another thing too, I'm going to tell you about this one. This is a doozy, okay? You've probably all seen, well, a lot of you, you know, electronic guys I was talking about. Some of the prospecting guys won't know. But you know these charging boards you get from Asia, and you put a lithium battery on the end, and you can charge. And anyway, these are a bit of a diabolical thing. What happens? It says USB-C, right? But if you use this to charge the battery, guess what happens? You cannot use a USB fast charger on this to charge the battery. This is what's happened to I know people who've used these, and if you've got an old USB A, you know, standard USB connector, and it's a USB A, you know, the first USB that ever come out, and it goes to a C connector, it will work, right? It'll work because if you use a C charger, like I've got up on the bench there, that's a C charger. Might as well show you this. Make sure it's on. Okay. These ones it will power because it's got two resistors connected to ground on the CC1 and 2 pins, which activate the charger and say, hey charger, please turn on, right? So there you are, it's on, not a problem. Here we go, USB-C, and it basically says get stuffed. There's no power, it will not energize the board. You've got to get on the fourth pin in that way and the fourth pin in that way and stick a 5.1k resistor to ground, right? Good luck with that, you can't do it. The pins will, even though you can just manage to get onto them, will not take solder. They will not. They've got some layer on them. You can't take the connector off. The whole thing is, you know, multi-point soldered there and on the pins. You take that off, it'll probably destroy it. And there's no pads there. So I don't know what you're going to do. So on these are in some way a very good charging thing if you're only using the old USB system. You can't use a USB-C. So guys, be wary of any products that you may have been using that have these in them, and you take them out and you say, oh, you know, I've got my setup there and I've got USB-C cables from a USB C type charger. You'll plug it in and you won't be able to charge batteries, and then you'll cry probably, especially if you're out in the middle of nowhere and you've paid a lot of money to do a big trip. So yeah, be wary. And if I use a normal USB, I'll go around here. I'll show you. If I go around here, that bit of pink paper there, that's called a Mark Zuckerberg filter. That's what he does, because people can remotely turn the cameras on in your computer. Did you know that? Not everybody, but CIA, Mossad, ASIS, or whoever, MI5, MI6, Russians, North Koreans. Okay, so if I've got this here, I think that's a USB standard, USB-A to USB-C, right? And I'll stick that in there, and not a problem. She's charging away, right? But do not put a C to C. It will not work. So I just thought I would point that out, because a lot of people out there are putting these in their rechargeable add-ons for detectors. Be wary. The way you got to fix it is that if you're using these WP4026 boards, that's what they are, you won't be able to fix it because you can't do anything about it. The other thing about these boards too, guys, is a lot of, I'll tell you this right now. I better explain this because I've done testing myself and proved it works. Well, this board will regulate beautifully. Well, that's two boards there, by the way, stuck together. But on here, you have a regulator, you have a little controller, and this one down the bottom here is a dual FET package, and that controls the output to the cell. So it actually senses current with that, and that's a regulator chip. What happens? You charge this, everything's happy, no worries. It'll charge, it'll detect the peak current flow and the right drop-off point where the current actually takes a dip, and then realizes that don't keep putting current into the battery, because then you're going to cause dendritic crystals in the battery and throw the battery in the bin, right? So that has to be accurate. But what people have done with some of the stuff, I'll tell you right now, on these, you got a USB charger hooked up to it, and you have the equipment hooked up on the output there. What it does, it confuses the current sensing in the regulator charging chip, basically. We'll call it charging chip. So what happens is that where it's meant to pick the knee in the voltage drop off, that's when they know when these are charged. The voltage changes and the current drops and then does something else. Can't remember the whole thing about it. I can read up on it and tell you about it. You can read up yourself. But what actually happens with the item left on, it doesn't detect the do not charge point and it keeps charging, right? And if you leave it on long enough, what it does, it will stuff the battery. It causes dendritic crystal growth, and that causes high impedance on the anode, and such you can't get current out of it. But what happens before that actually does happen? That needs a few times to happen, right? But if you leave it on, right, overcharge the battery, guess what happens? Starts generating oxygen in the battery. You now have a small hand grenade. It'll blow up. It'll catch on fire and probably burn your tent down or your house or whatever. Be wary of these. Just be wary of them. Okay? They're not really up to the job. And that's why if you go and have a look on any of the Asian websites, you'll see these getting flicked out, in one case, 26 cents each. I can't even buy the connector for that, right? Why are they that much? Because what's happened, everything's gone to USB-C. These don't work. Get rid of them, quick, quick, quick. We've got millions of them. And also about the other fire hazard with these, that they do not regulate the charge current to the battery if you have the device turned on. So be wary. I know I'm not going to say what it's, maybe I should do a safety freaking commercial, but I'm not. It's not my job. But I have seen these. I have seen these in various pieces of prospecting accessories. I have seen them with my own eyes because I've had them in the fix. So be wary. And the other thing too, I should point out, these ones will work, right? And they will charge your battery, but there's no protection, right? There's no protection. So if anything happens, you're going to get, well and truly, done over sideways. So be careful with all this Asian charging cheapy boards. Don't trust it. Research it. Find out what it is and go and read up on the internet, because there's a lot of people who've had the experience of first-hand effects. So, yeah, that's that. There's a whole heap of stuff that I go on about, but it just digresses from my initial video. See, no one will know about these exploding batteries and exploding chargers and all that problem because they never watch this far in. They'll say, oh, yeah, he's bouncing things near coils again. Oh, yeah, seen that. Bye-bye. And, yeah, that's why I should possibly do, different videos for different subjects because, it's a different material. So, anyway, we're back there. But, guys, if you do have any double D coils, preferably, I don't want a good one. I just want, if you've got stuffed ones that don't work, ones that got water in them, ones that, I don't know, they're very, very old and, you wouldn't use them again in a million years, that sort of thing. That's what I'm thinking of anyway. Yeah, so I'm going to have a time lag of getting some double D cable. That's the only reason I'm asking. So, yeah, let us know. Just send an email to, David at DetectorMods.com. I don't have my name at DetectorMods.com. That's funny, isn't it? Yeah, but it might be the. I think I've just got contact at DetectorMods.com. Yeah, because you know what happens when people find out who you are? I'm not being rude, but it's like you get 50 questions, right? You get no work done. You'll be sitting there answering emails all day. Sorry, it doesn't pay the, what does David say? Doesn't pay the mortgage. So, Yeah, you can't do it. You really can't. You can't just have a barrage of technical questions come in. I get it all the time anyway. Oh, my detector's doing this. What's wrong with it? This bit on the board's black and crispy. What caused that? And how do I fix it? What's the part number? You know, my God. You know, it'd be like ringing up your doctor and say, my left rib hurts and I've got a headache. What's the problem? He was going to tell you over the phone. No. So yeah, you can't get stuff analysed like that. It's impossible, especially with electronics. You can't just oh, the detector stopped working, smoke came out, or whatever. I just I don't know. I'm not magic. We can't just wishfully think a cure for these problems. It takes analysis, and you really need it in front of your face and measure, measure, measure. What did that part blow up because it just wanted to at that time? Was it a bit faulty on its way out, or did something else do it? Is there other stuff blowing up in there which has caused it to happen? Whatever, whatever. Yeah, I'm going on a rant at the moment, but that's all right. There's been a few people who make YouTube videos go on rants lately. So, oh dear me, it's amazing my voice has held up this long. It really is. Yeah, and the detector's still there, purring away. Oh, I'm quite pleased. It's so quiet in this room. It's very, very quiet since everything has been locked down, shielded properly, locked up, and yeah, it's not bad at all. Anyway, I got some more stuff I'm going to do. Um, I'm just going to be careful if what I talk about, if it's going to have any detrimental effect. But yeah, there's lots of things coming. By the way, you want to see the transmit winding in double D coil? That's your transmit winding, which I broke out of the foam. Yeah, there you are. Look how solid that is. I can't even squash that. It's all got. Well, you do remember I said something about you don't really want to put resin between windings, right? Well, that's got all resin between the windings, and the even worse was the receive winding. It was so brittle and stiff that I could just snap it into segments of copper. So it all went in the bin anyway. But that actually is a 300 microhenry coil, and I thought, well, I I could possibly use that for something. Don't know what, but stupid weird shape. But you can't bend it. You can't move this. You that's what you're stuck with. But I can make it to some quick test fixture or something. Yeah, but yeah, I don't even know if that's if that's really what I would classify as very fine litz wire. It really looks like the actual stranding of that's very, very, very thick. It's hard to tell with the lacquer, but if you look at the end here, where my hand is, yeah, there's not many strands, which um, yeah, depending how fast you clock your detectors, if you do get those cross-sectional eddy currents occurring. I don't know, but yeah, as long as they're under about, I think it used to be under zero point 0.2 millimeters per strand for the older detectors. I think they've probably gone to 0.12 now, or something like that. Funny about that magic number. As you can see, I'm using um, very, very small, little tiny targets, which are probably very equivalent to that, as in wire diameter to target size, and I can detect them. What do you think's happening with the coil? Do you think it's detecting itself or not? We'll leave that out there as a question. Anyway, that's all I'm going to do. I think there was something else. I'm just dagging around trying to think of something else I was going to talk about, but no, probably not. Not at this stage, anyway. Otherwise, I'll just out myself. But yeah, guys, be wary about those battery chargers. Open up your devices if you've got anything that has rechargeable batteries, and look inside. And if it's got a W, it has not written on it, but it's called a WP 2046 or 4026, one or the other. I can't remember. Yeah, blue thing, like I showed. Be wary. You cannot leave the device on whilst charging at the same time. It is a massive safety fire issue. Okay, so be aware of that. And on the other ones, beware as well, because you actually need all the charge monitoring stuff off the other board if you use it. So you can't win either way, can you? No, you're better off designing your own board and make it work properly with all the proper data bus comms and everything, so it'll work on A's, B's, C's, D's, E, F, G. It's not hard to do. God, those boards there. I don't know. You can't use them because of like 2 cents worth of tiny little resistors. I mean, God, that's terrible. But guys, just be wary of some of this stuff. There's a lot of guys out there who, well, I'll just say this, okay? They can hook up little electric motors to batteries and light bulbs and stuff like that, and they think they're an engineer, right? Like they'll build up electronic stuff with charge systems and that, and a lot of it, if it's out of where, my God, you have to go over it with a fine tooth comb. You are gonna be see. I've said stuff like this before about batteries and things, where I pointed out deficiencies in the actual designer stuff, and I had the wrath of God over it because I tried to protect people. I tried to say this is dangerous. I could just say nothing. That's not very moral, is it? If I just said nothing, so I will say stuff about it. I will. You got a damn obligation to say stuff like that. So just be wary of inbuilt charging in stuff. And like I say, open it up, have a look. You see those little blue boards in there, and that's it. And it goes onto the battery. Be wary as hell. And if you can turn on the device whilst charging at the same time, you'll see the red LED on the WP board light up. Right, that's danger. Right, if you plug something in and it doesn't turn on, and the blue LED, they use blue ones as well for end of charge or fully charged. If none of those lights come on and you plug, it will turn the thing on. It's with the charger in, that's fine because it's some isolation happening somewhere. But if you can use it and charge at the same time, danger, park ranger, be very careful, be wary. And if you're going to charge it, get a flame-proof bag to put it in. They sell them on eBay. You can get them anywhere. For lithium batteries, any equipment, stick it in a flame-proof bag. You don't want your house burning down because of some unforeseen event. So be wary. And you should do it with every battery, actually, just for the hell of it. Like I've got lithium batteries on charge here all the time. I've been doing, charging lithium batteries, I don't know, probably 15 years or something. I never had a problem. The only time I ever had a problem when I opened one up to try and fix it, and the tab was off, and I went to push it down, and it shorted onto the outer shell of the battery, and I had to quickly grab it, throw it in a bucket, and I threw it out the bloody front door and it went up in flames. So that's what danger can happen with lithium. You don't want to bash them, knock them, and just treat them with respect, because you turn your back on them and one day they're going to bite you. Just ask, you know, the e-scooter people and flaming Teslas and all the rest of it, flaming buses, all that stuff, all lithium, bang, boom. Yeah, anyway, I'll turn that off. Now they're droning away. Grab the other microphone, put them back on charge. So yeah, that's that little test there with all the hot rocks and the hot ground and everything else. So now you know, it don't make no difference. Anyway, people still probably say it makes a difference. It can, but not in depth. Not acting as a medium to get a signal through. It makes no bloody difference. Anyway, catches.